it's very hard to explain people what we are doing. And when it comes to RFID, people were saying it's not possible, it's not fast enough, and it turned out not to be enough to have a chip design simulation and showing them the results, or it was not even enough to have a chip that shows that we could measure we are using just below 5 microvolts and we are using that number of cycles, which would be okay, because when it comes to anti-collision procedures and stuff like that, it's very complex. You can explain everything, but it takes very, very long to explain that it works. So what we did is then we decided for a prototyping platform. Since we are not communications engineers, we didn't want to have an analog front-end design there, so we separated it. Then our partners from industry offered us to do the front-end chip. And then we asked them, okay, if you are doing the front-end chip, are we then allowed to publish our results? And they said, of course not, because the front-end is our thing. And then we decided to do it on our own with, you can look at it, it's rather simple design. It's not used to, it was not supposed to work passively, but it should be cheap, easy to design, work with standard readers, and come up with, and to show parts of the tag working, the digital parts. So important was that it was allowed to publish for us and that it's compatible with standard readers, so that we don't need to deal with the reader side again, because we're actually interested in doing the chips, only parts of the chips. So we came up then, first part was this HF version, supporting ISO 15693, which is not the MIFARE protocol, but similar to it, but for longer ranges, so up to 1.5 meters HF. We came up with a UHF version. We are having now the European UHF front end, not yet for the US. We developed then a programming framework that it's very easy to program them. So there is a library and you have access to this library, which somehow has access to the low-level parts of the protocol. But just introducing new commands and new functionality should be or is very easy. All you need to do is like implement your new functionality, define a new command, and define this new command also on the reader side, and then it basically works. We used this out. We started then to ship it also to research partners, and they were quite happy with that. We used it in several research projects as a demonstrator, for instance, in this SNAP project, which was like development of a coupon system where you could, the idea was that you could pick up protected, cryptographically protected coupons from passive RFID tags in a billboard. And there is quite some crypto ongoing then between the tag and this thing that you really can protect these coupons against copies, against forging, and against several caching and stuff like that. We built this. We used, instead of real tags, because we didn't have the budget to produce tags in this project, these demo tags, placed them behind the billboard so that people couldn't see them. And we got then a development award. And there is also, after kind of shipping them to several partners, we decided to provide them as a product on our website, and there are also people now not knowing us using our tags as prototype platform. So we went on with our things, using them. What we did then, we found out it's quite effective to demonstrate security holes in RFID systems. So we are interested in providing crypto security for RFID tags. We have to motivate people to go for security, and it's very effective to use this device and go there and say, look, this is your access control. It's supposed to be secure. Within 5 minutes, I can go in there without any problem. Most of these systems are completely unprotected, even in critical environments. So it's very easy. We use them in implementation attacks. Kevin was talking about today, like this research challenge, side channel analysis. It turned out to be very effective on RFID tags. So you can do side channel analysis attacks. These sort of attacks, you measure the power consumption of a cryptographic device and try to find out then about the secret key. In RFID tag, this means you measure the EM field around the tag and try to find out what this tag is computing. It turned out to be very effective on UHF tags because the backscatter is actually, the tag is scattering out the information, what it's consuming. That's what a backscatter is. So it's very easy to find out about the consumption of the tag just with a standard reader. It's very easy to attack them. It's very complicated to protect it. Because all these, there are countermeasures known, they use a lot of power, they use a lot of area. All these things you don't have on RFID tags, but it's a very interesting topic. We use then these tags for triggering the attacks, which is somehow necessary for this attack, so thank you. And yeah, meanwhile, there are first real world tag products out there which use the demo tags in their development phase. So the framework, I will not go into detail. I have a demo up there. I can show you then, and I can talk. I can explain you also about the framework then. The idea is that it's to be used in academic and research environments, and we want to share with you this platform if you want. Now I want to explain you a little bit how we use them. So we are also teaching. A lot of students work with these tags. They are investigating about the theft control, high advanced theft control in our library system. It took them half a day to break it. Also the access control to our parking is somehow investigated by our students. We use them to